Okay, so now we've listed sets, by listing the elements. And we've listed sets by listing some elements and giving ... to indicate a pattern. There's another way to describe a set, and that is using what's called set builder notation. So what we do is we say something like this. Like, for example, so this over here, this is the set of, so the way to read this is the set of all x in the integers. In other words, it's a set of all integers such that this condition is satisfied. So it's a set of all integers which are even. In other words, a set of all even integers. So you could write this out using the previous set notation which we mentioned like this. You could say, well, this is ... minus 6, minus 4, minus 2, 0, 2, 4, 6, ... Yeah? Say it again? It is, sort of, yes. I mean, it's difficult because some people would just write down x. Another way you could write it down, the set builder notation is not sort of unique. There's usually lots of different ways you can write down the same set. You could write this down like this. Let me write this in blue. As you could also write it like this: the set of all x such that x is in z and x is even. Or, you could write it down like this. If you were happy with the fact that something which is not an integer could never be even, you could just say the set of all x such that x is even, and leave it to the reader to figure out the fact that you must only consider integers. Yeah?
Is 0 strictly an even number?
Yes, 0 is an even number. And so are the negative ones, yeah.
Okay.
Yes?
If we write it as a set of 2x, that's that x is an integer.
Yeah, you could write it that way as well. So that's another way of writing this down. So you could write it as the set of all 2x such that x is in z. That's another way of doing it. So there's usually not just one way you can write down a set in set builder notation. There are lots of different ways usually you can write a particular set down using set builder notation. One thing I want to mention about the way I write set builder notation in this course is you might have seen this before with this. With a vertical line in the middle instead of the colon, yeah? How many people have seen that before? I've seen it before as well, so I'm going to put my hand up. You can do that. The reason why I prefer it the other way around is because if you write down set builder notation for something in which there's a condition on the cardinality of the set, then it looks ugly. Yeah? So, for example, if you say, let me just say over here, the set, let me just, what's a good way of saying this? The set of blah, 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 I'm having trouble thinking of a concrete example, such that, or the set of all, let me say the set of all sets, or set of all subsets of the real numbers, such that, with a line, the cardinality of S is equal to 3. So there we go. See, it just looks a little bit non-aesthetically pleasing. Because now you've got these two vertical lines right next to each other, and one means cardinality and the other one means such that. Yeah? So I prefer the colon for that reason. But you can use vertical lines if you wish. I won't, no, I won't penalise you, actually, no. No, I won't, I promise you. But at least if I penalise you, I will hide it so that you won't be able to tell. Okay, so now, using set builder notation, we can define Q. Right, so Q is a set of all m over n such that m and n are in Z and n is not equal to 0. So that's the rational numbers, right? If you want to be more precise, by the way, you should actually say not the set of all m over n such that m of n is in Z. So it is 2 rational. Yeah, the integers are all rational. But 2 is not m over n, right?
In a way, it is.
Why? In what way?
Your n would be 1, and then your m would be 2. Both m and n are integers, and your n would be non-zero.
Yeah, so, but that's slightly, this is a subtle distinction, which is the point I'm trying to make, so it's a good, yeah. So 2, as I've written it there, doesn't satisfy this definition. 2 can be written in this form, however. That's slightly different. Hmm? So, yeah?
So if you express 2 as
Yeah, so that's exactly, yeah. So at the moment, the way I've written the rational numbers down, 2 is not a rational number. So maybe what I should say instead is, I should say, if I want to be a little bit more precise, I should say the rational numbers is a set of all numbers, or all real numbers if you wish, which can be written in the form m over n, where m and n are integers and n is not equal to 0. Just for maximum precision. Okay. So let me write it down. So maybe better. Let me write it. Okay. So maybe better. Maybe better. Q is equal to the set of all. Let me say x in R, such that x can be written in the form m over n, where m n is in Z. Or I should say for some m n in Z with n not equal to 0.
Coming to the Monday's argument, how would you say x element of R when we haven't defined R?
Yeah, well, no, I know we haven't given an exact definition of R, but that's a long stand. That's not my problem. You must go back to your high school teacher in about grade 8 or something and say you didn't define R, because you've been using it ever since then, right? You didn't complain to your high school teacher about that. So why are you complaining to me?
No, because they gave me R from whole numbers, integers,
Yeah.
and they defined R.
Yeah.
And I was
But now you know that it didn't really define R. But we're going to get to that later. We're going to pretend that we know what R is, and then later on in the course we'll probably define R. Yeah. Other questions? Yeah.
How do you use set notation with a split domain function?
Say that again.
When you use split domain, how do you use set notation with a split domain function?
With a split domain function. What do you mean?
With something that has a domain. Set with domain.
Something that has a domain which is
Like a circle.
a circle. Oh, so I mean, then you could define the circle. So I mean, you could start off by saying let C be the set of points on the circle x squared plus y squared is equal to 1, and then say this is the set of all x in C, where the x is there understood not to be an x coordinate, but just a general point in a set on C such that blah blah blah. Is that? Other questions?